Hello everyone, how's everybody doing? I hope you're doing fine. Today we have a little change in plans. I was planning on continuing with 18th century spilling over into 19th century ether, electricity, magnetism, and but I had a little emergency come up. I had some people who fell behind. They are confused and they don't understand certain things, specifically about the ether, specifically about the vacuum, space, etc. And sometimes you got to make a little detour and explain these things in a little more detail, what the problem is. Okay. And right now, these people can't seem to follow along. I don't know if they're just flyby, they're just people who read or listen superficially and then continue. But I'm not only going to be discussing for them, I'll be discussing for all other people who might have similar questions or similar issues going through their mind, like how do you answer this, how do you answer that. So I hope to cover some of those bases today. Maybe I'll cover them all if I'm lucky. Okay. So what am I talking about? I'm talking about the ether and how they relate to space. How this thing called ether relates to space. We've been talking about that since March. I checked the other day. Since March, we've been talking about what is it? 2 months now, 3 months. And the first thing we need to clarify what this site is about, because that's a great part of the problem. And people think this is over here that this is business as usual, and it's not. Here, this is totally different. What we're talking about here in this site. People say, well, everybody says that, everybody thinks they're different, that they've got something to offer, that they have a new theory of light, a new theory of electricity, a new theory of magnetism or the universe or whatever. And so they believe this side is just another one that makes the same claim. That you're all the same, you're all claiming that you're different. Now, this side is genuinely different. And those who read my Quora articles are very much aware of that already. It's a little different than what you read out there, what you see out there, what you hear out there, okay? And what is different? Well, first of all, we're saying that all of mathematical physics, all of it, from Newton all the way to this bozo that died the other day, a couple of years ago, Stephen Hawking, it's all nonsense. It's all garbage, all trash. All of it can be wiped out. All of it. Nothing survives of mathematical physics. Nothing. We're saying that also that, this nonsense proposed by mathematical physics, particles and waves, that's swept away as well. No particles, no waves. Now, if that's not different to you, well, I don't know. Then maybe you haven't read enough about what the scientific literature, what that's all about. So we're saying that all of mathematical physics, specifically quantum mechanics, general relativity, string theory is all trash. Electric universe, garbage. Ken Wheeler, nonsense. Eric Dollard, nonsense too. Haynes Alfman, nonsense. Tesla, nonsense. All of that is garbage. We throw it all down the drain. None of that survives. Now, if that doesn't sound different to you, well, I don't know. Again, you're not in touch with the literature. Here we're saying we're going to lay, for the first time in the history of human science, we're going to lay the foundations of physics. We're going to lay the foundations of science. We have a new definition of science. The correct definition, we believe. You don't have to believe us, but that's what we're going to propose here. We have a different version of what science is, specifically as it relates to physics. We're interested in physics, not in any other branch of science. So what are we saying? We're saying that physics is about objects. Mathematics has nothing at all to do with physics. We don't use mathematics in physics. And people say, well, Bill, because you don't like math, you don't understand it. No, I've taken my share of math courses, and I clean my nose holes with all the math books ever written, with all the equations ever written. We don't care about equations because they have nothing to do with physics. Physics is about physical interpretations, understanding how a magnet attracts another. I want the mechanism. That's what we're going to deal with here. We're going to deal with mechanisms. We're going to deal with how light does its magic. We're going to deal with how electricity works, how magnetism works. We're going to deal with how the atom works, okay? And also with cosmic phenomena. You know, this nonsense called black hole, this nonsense called dark matter, you know, that they invent to cover holes. We're going to completely wipe that out, swipe it completely away, brush it away. None of that survives. What we're proposing, we're proposing two things. First of all, we're proposing that all atoms in the universe are interconnected, physically interconnected. No one has ever proposed that in the history of human science or physics or whatever. Everybody's been dealing with one-way waves and one-way particles. Everybody's been dealing with particles and waves. Everybody's been dealing with discrete entities. And we're proposing here that all atoms in the universe are interconnected, physically interconnected. They're interconnected by a DNA-like rope. Light is a torsion along a rope, not a transverse wave, not a longitudinal wave. It's a torsion, a three-dimensional torsion along a wave, along a rope that interconnects any two atoms. That's why light is swift. That's why it runs at 300,000 kilometers per second. There's nothing that you can imagine, no rocket, nothing we can imagine that is faster than a torsion wave along a rope. And you can do this experiment at home, which I've done, and I've even filmed. Take a rope, tie it from one wall to another, making sure it's tight. Put two clothespins at either end. Move one of them, the other one moves instantaneously. The tighter the rope, the faster it goes. That's how fast a torsion wave is. It leaves longitudinal and transverse waves, biting the dust. They're turtles compared to this cheetah that's running. Okay, but that's not the most important part. The most important part is we're presenting a new language. And the language that we're proposing is that you cannot introduce ordinary speech into science, which is what mathematical physics does. Mathematical physics, quantum mechanics, general relativity, not only do they introduce notions of ordinary speech, notions such as object, what is an object, what is the dimension, all these words, all these crucial words of physics. But they introduce concepts and turn them into objects. They reify, they turn abstract concepts into solid objects. They take energy and turn it into an object. You heard of transfer of energy. What are they transferring? Transfer is a physical phenomenon. You can transfer a dog, you can transfer a cat, you can transfer a tree, a rock. You can't transfer information. There's no physical object called information. Information is what the other guy receives and understands, not what you transfer through the line. What you transfer through the line, if anything, is maybe some signal. You can say it's electricity, whatever, but there's no information. When you read a paper, no one transferred information to you. They transferred a piece of paper and you're reading it, you're understanding the information. You can't say you transferred information. And you can't say you transferred energy. You can't say you moved a mass. You can't say you vibrated a field because there are no such physical objects in physics. So we're changing the language here. And unless you're tuned into that, you're going to miss a lot. And that's the subject of today. The subject of today is that, someone is worried about the ether. The ether is his bread and butter of his theory, of his religion. And so when you tear down the ether, the ether fanatic, starts worrying. He says, hey, you're raping my virgin. I don't like that. This is my idol. You're going to tear it down. My whole religion you know, falls with it. And yeah, this is the problem. The problem is that that's what we're going to be attacking here today. We're going to see if the ether holds its weight, so to speak. Okay, so let's get started here. It starts with a fella who comes in there and puts a comment the other day. He wrote extensively, so I thought I'd address some of the issues that he raised because it was in tune with what we were discussing. Obviously, we were discussing the ether. We were talking about space. We were talking about the vacuum and how electricity and magnetism relate to that. We've been talking about William Gilbert. We've been talking about Huygens and Isaac Newton and Descartes, all these great philosophers of the 17th century or thereabouts. And so he was on topic. He wrote extensively, criticized me, and that's good. That's his job, okay? But I need to address these issues, again, not only because of him, but because people out there might have similar issues. They might have these questions in their mind. They say, how do you answer this? How do you relate? How do you respond to this, okay? Okay, so let's start with what he put up there. He puts the following. Let's see if we can put this up there, okay? And he writes the following. He says, Bill is trying to confuse you with his rhetoric, like adjectives and stuff, and avoid a study of the ether medium. Well, not really. I'm really want to get to the bottom of the ether, and we're going to do that today. I want to get. I thought I did, but if people are confused and they don't understand some of the concepts, I really want to get to the bottom of it. I want to study the ether. Now, I want to caution you that, and this is important to note, that this fellow is, he moves on to discuss what the ether does. We don't care about that. We're not going to get into that. We're going to get into the nature of the ether. That's what we're going to spend 2 years on, because that's the problem. Okay, so let's make sure we understand the context here. Context is, I'm not going to be addressing what the ether does. Nobody cares about that. Because if there is no such thing as ether, you're wasting your time talking about what the ether does and all the magical things it does. So the first thing we have to determine, what is the ether? Does it qualify as an object, as a medium, as a whatever, for the purposes of physics? That's the first step. If it doesn't qualify, we don't need to worry about what the ether does, because you're talking about spirits. So let's make sure that what the context is here. Okay, let's put that up again. Okay, so he says the ether medium vibrates. Okay, we don't care about that. And that vibration is light. So he's saying that light is the vibration of the ether. Okay, and that's pretty standard. He's essentially stating what most people understand by the ether out there. He says Tesla, he's quoting Tesla here. The ether is not a solid. It is a fluid that flows around an object, just like water flows around a ship or air flows around an aircraft. Okay, so his description is pretty straightforward. He's saying it's some kind of, this ether thingy is some kind of fluid, and it goes around objects. Okay, straightforward. Tesla said that the ether medium is the magnetic field we see flowing around all moving charged bodies. Okay, so now we have the first problem. The first problem is that word field. There is no physical object called field. We already covered that, but I'm not going to do that today in any detail. But there is no physical object called field. Field is a concept that the mathematicians have turned into a physical object in order to get their physical interpretations out. But there is no such thing as field. Faraday invented the word in the 1840s. Probably even earlier in the 30s, but he started using them formally in his presentations to the Royal Society about 1844, 1845. He invented the word field. He was referring to a magnetic field specifically. He may have also related it to electric fields, but the issue is that he invented the word and it means region. It's a region around a magnet that he doesn't know. It's essentially a field is a sign of his ignorance. Faraday was an ignorant man. He did not know, he had no idea what a field is. So he said, look, there's this region, it's got all these lines of force, and it creates this force on things that has this effect on visible matter, and I'm going to call that region, that unknown, I'm going to call it a field. Well, from there, the mathematicians until today, in 150 years, what they've done is turn that ignorance into a physical object. They said, okay, we have the field, and it's a vibrating thing that's out there in the vacuum, and this vibrating field is what a particle is. That's how they've turned this around, okay? That's what they've done with the word field. But let's continue. Ether is like water or an atmosphere on a planet. There is an end to it, okay? So he's saying it's got limits. It's a finite object, finite medium, okay? We're going to find out medium and object mean the same thing in physics, but he didn't know that. Okay, fish can't get out of the water and sound cannot get away from the Earth's atmosphere. So we cannot know where the universe ends. This is not a question of knowledge. It's not a question of experiment. It's a conceptual issue. If the ether is finite, it ends somewhere, we're done. We don't care where it ends. We're not going to take a spaceship to find out. It's a conceptual issue. It ends, fine. That means we can draw this thing because this thing is finite. Okay? Because anything outside of the ether of the universe cannot be observed by us. Again, we don't need to observe anything. We don't need eyes for this. All we need is conceptual, mind. We need brains for this, intelligence. The ether is a continuum. No such thing. No such thing as a continuum. Okay? Especially if the ether is made out of particles, then it cannot be a continuum. It's a discrete. It's made out of segments, out of pieces, okay? Particles or whatever. The ether is a continuum of the ether fluid that has to end somewhere, a fluid unto itself that has an end. Okay, so it's a finite object and we don't care what it's made out of. What we care about is the whole shebang. The whole thing is what we call the ether. We can point to the air, but we can't see the effects the air has on moving objects, right? Okay? Okay, the medium is dipolar particles, okay? So he's saying that this thing is made of dipolar particles, whatever that is, okay? Positron, electron pair, again, whatever that is, okay? He's saying that we have these two particles, whatever they are. One is a positive and one's a negative. We never know what those things are. Those are mathematical nonsense that mathematicians pour in there. They put a plus sign on one, negative on the other, and you go figure out what that means in physical terms. Okay, so they say they have a positron electron pair. Great. Okay, that slightly repel each other. It is clear that the ether is a medium, not a solid object. Nobody's saying that it's a solid object. Okay, he's saying it's a medium. He doesn't understand the difference between medium and object. Medium and object are synonyms, perfect synonyms in physics. Medium entity, we're going to get into that in a minute, but right now I'm just going to state that medium and object are the same thing, so he's just repeating his words there. It is clear that the ether is an object, a medium, okay? It has shape, it has an end, it's finite, that's what he's saying. The only thing solid about the ether medium is the individual particles that make it up. Okay, so he's saying it's made out of particles, okay? It's finite. And let's see if we can synthesize it here. See if I've got it here. Yeah. This is what this fellow, his name is Joe Degelman. He's saying it's made out of particles. It's fluid, like water or an atmosphere, moves around objects, has to end somewhere. Okay, so it's finite, right? Fluid that has an end, and it's a medium. Okay, I think it's clear. And in fact, I have the definition of the Wikipedia, which pretty much is consistent with what he just said. He says, according to ancient and medieval science, ether is the material that fills the region of the universe above the terrestrial sphere. Okay, the concept, not an object. Whether, so we got to keep that in mind. We don't move concepts in science. We don't move love. We don't move information. But they say it's a concept. Again, means the people who wrote this in the Wikipedia have no idea what the difference between a concept and an object is. We're going to get to that in a minute. But let's continue. The concept of ether was used in several theories to explain several natural phenomena, such as the traveling of light and gravity. In the late 19th century, physicists postulated that ether permeated all throughout space, providing a medium through which light could travel in a vacuum. So Joe Degelman and the Wikipedia pretty much are on the same wavelength, okay? They're saying essentially the same thing, okay? They're saying we got a medium out there, finite medium, made out of particles, And so it's a fluid medium. It's waving, I guess. That's what they imagine, and that waviness is going to be light. Okay, that's how. Essentially, what they're doing is repeating what Christian Huygens said in the 17th century. We've already covered that. Okay, a couple presentations ago, a couple lectures ago, and that's what Huygens included in his treatise on light, okay, in his book. And Isaac Newton did not like that, so they had this tete-a-tete, this fight between them, okay? Intellectual discussion, I guess. Okay. Here we have, let's see. This is Joe's ether, essentially. I hope I'm not misrepresenting it. This is the entire universe there, okay? And he says it's finite, okay? And all those little particles that are waving there, moving around, that's the ether. That's what he's thinking about when he says ether, okay? And I hope, again, that I'm representing it correctly. Okay, so what is the problem? Well, Joe makes reference to a paper by a lady whom he calls the fractal woman. Yeah, and I guess that's the name she uses in her Twitter account. So I sent her a message to see if she wants to listen in, because since I'm going to be talking about her theory, the one she published, or she's got in a paper in ResearchGate, I thought I'd, invite her as well. I don't know if she's going to watch it or not. But the point here is that this lady, Lori, she says something totally different. And obviously, a fellow like Joe, who is not very deep in his thoughts, just glossed over some of these things. Okay, and again, it shows that the people who propose ether, they're not getting to the bottom of what the ether is. They just kind of superficially go over it very lightly, and they continue and they say, "Let me show you what the ether can do." No, I don't care what the ether can do. Let's fix the ether first. Let's find out what it is. Let's find out if it belongs in physics. Okay, that's the issue. And here's what she says. Where is he? This is a paper by Lori Gardy. I just pulled some key issues that are pertinent to what we're talking about here. It says the vacuum of space is not empty. It is just empty of matter, but full of ether. Okay? Well, we already have a major problem there, because she says the vacuum of space. I thought vacuum and space were synonyms. And she's saying that they're not empty. And then she fills it with ether. So she's got three words here, okay? She's got vacuum, space, and the question is, what is vacuum, space? What is either of those two words different from nothing? I thought vacuum, space, nothing, void were all synonyms. And she's saying the vacuum of space. It's like saying the vacuum of vacuum, or the space of space. What is she talking about? Obviously, she hasn't done any deep thinking about this. And the other issue is that she says it's filled. What do you mean filled? Full of ether? What do you mean it's not empty? Are we saying that space is some kind of container? Is it a hat where you put coins in? Is it a funnel where you pour water into it? Is it a cylinder that contains something? Is that what space is? Is space something that you fill? Does space have borders? Does space have a surface? Are we going to put things inside space? Can you put things in nothing? Is nothing a medium? That's the question. That's what we're going to be dealing with here, okay? So she says the vacuum of space. We got already a contradiction there. That means she hasn't done any deep thinking on this. She says, then she continues, the vacuum of space consists of a medium of bound electron-positron pairs. Again, she equates electron-positron pairs with the ether. So, the ether of the 19th century was a little simpler. Today we made it more complicated. They say it's not made of particles, just any old particles, classical particles. No, it's made out of quantum electron-positron pairs, which means negative particles and positive particles, whatever that means in physical terms, which they never figured out. It's just mathematical gibberish. That's all it is. And she says, this is, for all intent and purposes, Dirac C. Okay, so let's pull up Dirac C from the Wikipedia because this is an important point, and this is where Joe missed it completely. The Dirac C is a theoretical model of the vacuum as an infinite, not finite, infinite sea of particles with negative energy. So what is the Dirac sea? The Dirac sea is a bunch of particles that extends forever because Dirac wasn't smart enough, and none of the mathematical physicists are smart enough to figure this out. So they use the word infinite. That way you don't get to question them. See, with infinite, they stop all questions. They say it's infinite. And let's deal with the Dirac sea and what it can do, and let's forget about what the Dirac sea is. See, that's the issue. And so Joe is talking about a finite ether, and here this lady, she's talking about an infinite ether. So is the ether finite or is it infinite? Does it have shape as a whole or doesn't it? And if it does have shape, what continues after that? That's the issue that we have. So we're going to get to the bottom of this ether thingy to find out what it is before we can do anything with it, before we start moving it around and vibrating it. First, we need to find out what the ether is. And until we know what the ether is, we do not have a theory. We cannot continue. We cannot even incorporate it into physics. And she continues. She says, transverse electromagnetic waves can propagate in a BEC, Bose-Einstein condensate, when it consists of atoms with dipole moments. The author, she's referring to herself, the author is leaning towards a BEC consisting of particle-antiparticle pairs, okay, fine, generalized as vortex-anti-vortex pairs as the medium for the propagation of light. Again, everybody thinks of the ether as made of little particles, and that these particles vibrate, and that's what light is, the propagation of light. That's essentially 120% what Christian Huygens said in his book, Treatise on Light, in 1690. That's when it was published. So we haven't made any progress since the days of Huygens, okay? The only progress was made from Huygens from Robert Hooke, who came up with his wave theory of light. He's the first guy to propose waves in his book, Micrographia, okay? The medium that supports the propagation of light waves is deduced to be a medium of bound particle-antiparticle pairs, okay? So what is the issue? The issue is that we have Mr. Joe, and Joe says the ether is finite. And Lori, this other lady, the fractal gate lady, she says the ether is infinite. And they don't worry about that anymore. They say, okay, I've stated my case. Now let's move on. I'm going to be doing light now. No way. No way. We stop there because we have a problem already. First, we have to decide if the ether is infinite or finite. Okay? And then we have to find out if it's finite, what continues. And then we have to also figure out what gives background to each of the ether particles. Because if we're talking about particle-antiparticle pairs or positrons and electrons or whatever garbage quantum comes up with, we don't care. If they're going to come up with all these virtual particles and fields and energy and all these fancy words that they've invented in mathematical physics, what we want to know is what gives contrast to them. I want to know what energy looks like. I want to know what a field looks like. I want to know what a virtual particle looks like. And if we're going to talk about a classical particle, a corpuscle, there better be a background. And otherwise, what are we talking about? What is a particle? You know, if you're going to model your ether with little particles, and you're going to call them particles, and you say these particles vibrate, then you're talking about classical particles. I don't care how you twist and turn the thing, you're talking about classical particles. That's what you're saying. That's what you're interpreting. That's your physical interpretation. And you cannot say, well, I was only kidding. You shouldn't take that literally. No way. If you're going to say the space is made out of particles, that your ether is made out of particles, that your vacuum is made out of particles, or it's filled with particles, whatever way you phrase your nonsense, then you're talking about classical particles. Otherwise, what is the meaning of the word particle in that context? What is in there? Is it a what? Is it a thing? Is it an object? Is it something? What is this so-called particle that you're referring to? How is it different than the empty space? I mean, if a particle is just a concept, well, we don't vibrate concepts in physics. Not in physics. Maybe in religion. Maybe in your Sunday school. But not in physics. In physics, if you're going to vibrate something, it's got to be a thing. And for that, we have to define what a thing is for the purposes of physics. That's the starting point. We're going to get into that in a second, if I have time. Hopefully I get to it. Okay, so here we have... no, wrong one. This is the direct sea, the infinite ether. As you can see, the borders are artificial that I put there, but you have to consider this as extending indefinitely. Okay, that's all these particles just fill the entire universe, whatever that could mean, because they're saying that doesn't end anywhere. And I don't know what that could possibly mean. And again, that doesn't mean that you got to do an experiment or go out there and see it from God's eye perspective, from a bird's eye perspective. No, this is a conceptual issue. This is a conceptual issue. There's no object that is infinite. And these people are saying that this object called ether is made of particles. Not that the particles are the ether, not that each individual particle is an ether, but that the whole shebang is an ether. The whole bunch of particles is the body called ether. And if that's an ether and it doesn't have shape, in other words, it extends infinitely, whatever that can possibly mean in science, then we don't have an object. That's what it is. So we have a contradiction. So let's first show the difference between Joe and Lori here, okay? Here's Joe's finite bunch of particles and Lori's infinite bunch of particles, the direct sea. That's what they're saying. One guy is saying the ether has shape. You know, it has shape, it's moving, yeah, but I can take a snapshot of any one of those and whatever I have in my snapshot will have shape. And Lori says that her ether doesn't have shape because because I can't take a snapshot. And the reason I can't take a snapshot is I'm inside the ether. See, the only way you can take a snapshot of the ether is if you're outside the ether, in which case it would have shape and it would be finite. And she doesn't realize that. She's not smart enough to realize that, okay? So she says it's infinite, but it's an object. It's a physical object. It's a bunch of particles. And let me just continue telling you about light. No way. First, we want to see a picture, a snapshot of your ether. Joe's ether, at least we can visualize. We say, okay, we got an ether there because it's finite. Now I can do something with this ether because I understand what I'm looking at, okay? And again, we don't know what an infinite table looks like, okay? People say, the infinite ether. What does an infinite table look like? You're inside the table and you can't, how do you know it's a table? How do you know it's not an elephant? Why don't we call it the infinite elephant? Is there such a thing? And this is the issue. The issue is these people are using words and they don't know what they're saying. They lost track of what they're saying. And so that's why we're going to get to the bottom of the ether. Believe me, I'm going to ridicule the ether until, you're out of there. And no more ether. Garbage. Okay? We kill Christian Huygens together with everyone who thought about the ether. All of the 19th century idiots, we get rid of all of them. Okay, because they dealt with the ether all the way to Michelson and Morley and beyond. Even Einstein said, what is it? General relativity cannot live. He said, in other words, 1920 conference at Leiden University. He said, general relativity cannot live without the ether. He just changed the notion of the ether, but he was still using an ether. And as Laughlin, Nobel Prize guy, said, the modern version of the vacuum, the quantum version, is an ether. But we don't call it that because it's taboo. So they don't like the word ether. If you put the word ether, they're not going to publish your paper. So you can't use the word ether. It's just prohibited. It's taboo. You can't use that. But it's an ether. What is an ether? Bunch of particles. That's what ether is. Bunch of particles. That's the meaning of ether. As long as you use the term or the phrase bunch of particles, then you're going to understand what the ether is. The question is that what space is? And if space is not a bunch of particles, if the bunch of particles is within space, then you got to tell me what space is. What is space without the ether? What is space that gives shape to each ball that comprises the ether? That's where we're headed. I'm going to put you against the ropes and I'm going to pummel you on that issue. And I'm not going to let you go until you finish that. I'm not going to let you talk about light. I'm not going to let you talk about electricity or magnetism. You got to fix the ether before you use anything else. And you're not going to be able to fix the ether because it's an irrationality. That's what we're getting to here. Okay, so why is Laurie's ether irrational? Because there's no such thing as an infinite ether. We covered that last lecture. Okay, what's wrong with the infinite ether? It's not an object. It violates the definition of the word object. What is an object for the purposes of physics? It's that which has shape. What is nothing? It's that which doesn't have shape. So now we know the difference between an object, something, and nothing. Something is that which has shape for the purposes of physics, okay? And nothing is that which doesn't have shape, okay? So that's where we stand. We stand on the fact that the ether cannot be infinite because if there's no such thing as an infinite object. There's no such thing as an infinite medium because the word medium and object are synonymous in physics, okay? Either the thing has shape or the thing doesn't have shape. Either God has shape and is an object or God is a concept. God cannot be both, an object and a concept. God either has shape and is this magician who made the universe. He's a human-like, made us in his image. That's the object, God the object. Or he's a flaming bush, fine, burning bush. That's an object too. We can all picture those two things as objects. Or God is love, God is spirit, God is intelligence, as Deepak Chopra says, another bozo. You know, if God is intelligence, he's not a physical object. Is that what you pray to a concept? Is that concept has an ear and listens to your prayers and say, oh yeah, I'm praying to a concept. I'm praying to the concept love. I'm praying to the concept grace. I'm praying to the concept intelligence. Does intelligence listen? Has an ear for your prayers? So God cannot be both. God cannot be a concept, an abstract concept such as love, and also be a human being who created the universe. Okay? You got to choose. You got to know which God you're praying to, okay? And that's the issue here. The issue is that the mathematicians have turned all their objects into concepts, and concepts into objects. They use them as both. What is energy? Well, we transfer energy. What do you mean you transferred energy? Can you draw energy so I can see how you transferred it? I can see the movie of energy transferred moving through the screen. What are they going to draw for energy? What are they going to draw for a field? I mean, is there a standalone field that they can bring to the conference and put in the middle of the table so that we can all watch it? Oh, that's a field. Now I understand. No, they can't bring a field because a field, especially Faraday's field, is a dependent object. Faraday's field depends on the magnet. You take the magnet away, there is no field. You can't remove the field from the magnet for some reason, right? It's a dependent object. It's like the angel's halo. Without the angel, that's not a halo. That's just a ring or a plate. In order for the halo to be holy, it needs that angel underneath it. It's a dependent object. And magnetic field is the same thing. You don't have a standalone magnetic field or electric field. You need that thingy there to be associated with it. And the question is why? We need to figure out why that's the case. Why the magnetic field is tied to the magnet and you can't separate the magnetic field and say, I just want the magnetic field. I don't want the magnet. Can't do that. And that's the issue here. The issue is that, these people are confusing objects with concepts, and they're treating concepts as objects. Ether is a concept. It's not an object. So you can't say the ether wiggled or moved or vibrated or anything like that. Okay? Okay, so let's continue here. Where am I? Okay, there was a second issue. Second issue with the ether is, again, that you have to see it from a distance. If you take Joe's finite ether, fine. We can deal with that one. He says, look, ether is finite, it has shape. Okay, fine. We don't need to know what shape it is. We need to know whether it has shape. It's a yes or no type of question. It has shape or it doesn't have shape. Okay, that's the issue. Okay, the issue is, again, God either has shape or God doesn't have shape. God cannot be both. You cannot say, well, like some students in in Aberdeen told me a few years ago, some Muslims, and I had a debate with them at the dinner table, and I said, is your God a concept or an object? And they had all kinds of answers. Some said, well, he's both. And I said, well, if I knew, he wouldn't be so great, and so on. The standard answers they give you. But the guys who said, well, God is sometimes an object, sometimes a concept. Well, what is he at any given point in time? He can only be one or the other. And either he's this human guy with a magic wand in his hand making the universe, or he's love. You can't have it both ways, and you got to know which one you're praying to, right? And that's the issue here. Okay, so what's the issue? The issue is here we have one of the problems with the ether. The ether is, according to these folks, the vibration in a localized area. We have a little wave. And they say, look, that wave is vibrating, is ether that is vibrating locally. Or you can say light is the vibration of the ether. Well, that's not correct, see, because ether does not refer to a localized region of ether. Ether refers to the whole shebang. Ether is that whole thing is the whole universe. That's what ether is. Ether is not localized. Let me give you a for instance here so that I put you in the right place, in the right context. Here's water, okay? And we have a little fishy there in the Atlantic Ocean, okay? We have the word ocean. Can we say that the fishy warped the ocean? No, we can say that the fish warped the water around him, vibrated or whatever, the water that's in his vicinity. If you're going to talk about the word ocean, you got to stand way far away from the ocean. And you got to look at it from a bird's eye perspective, like in the bottom picture on the left there. You can see the Atlantic Ocean, and you have two walls on both sides. One is Europe, the other one is USA. You can say Africa and South America, it doesn't matter. The Atlantic Ocean is finite. Why? It's finite in the sense that, it continues all around the planet. But if we're going to talk about an ocean or a lake or a creek, it's finite. It begins, especially a lake. It's a hole in the ground. It's contoured all around. It's got land all around it. And the fish, you cannot say he moved the lake or he vibrated the lake. You can say that the fish vibrated the water, not the lake. Likewise with the air and the atmosphere there in the center. Air is a portion of the Earth's atmosphere. Okay, so you can say all these molecules and atoms, they comprise the air. Okay, and you can say, look, the air vibrated, meaning that the atoms and molecules in your vicinity, near your mouth or whatever, vibrated. But you're not vibrating the entire atmosphere. What you're doing is just vibrating it locally in that air, that region near your mouth. We call them molecules or atoms. That's what you vibrated. Well, the ether is similar. The ether refers to the whole shebang. And what these people are saying is that you have a little piece of that, okay? And that's going to be the wave. And they're going to say, look, we vibrated the wave, or we vibrated the ether in localized. No, you got to have a different word for that, because the ether refers to the whole body of particles that fills all of space or all of the universe. So if you're going to talk about a region within that, a small region, you got to give it a different name. You can't say the ether is vibrating, because the ether refers to the ocean, to the atmosphere, not to a localized region of the ether. Okay? So we got to get the language straight. We can't say the ether vibrated. Ether is the whole, refers to all the particles in the universe that form that backdrop, that space or that fill space or whatever these people have in their minds. So you can't say the ether vibrated. No. Now we're going to talk about something else. Now we got to give it a different name for that localized region. We can't say that's also ether. No, ether is the whole thing. Okay, so that's important to separate those two concepts. So Joe has the ether vibrating, but we remove that vibration, and here we have the ether. This is the shape of the ether. But see, it's moving, and we don't have objects that move in science. An object, the word object is a static concept. You point and you name. That's how we identify objects in physics. You point and say table. And now the ET understands the word table. And you point, you say chair. Now the ET understands the word chair. Lamp, dog, tree, rock. That's how objects are introduced in physics. You point and you name. You can only point from a distance from the object. And the object has to be there with its shape in front of you so that you see the whole shebang. You see the whole thing. You see the whole chair. You can't be inside the chair saying, I'm pointing to, you can't be inside the ocean and saying, I'm pointing to the ocean. No, you're not pointing to the ocean. Maybe you're pointing to water, but you're not, or to molecules, but you're not pointing to the ocean. Ocean, you got to be outside the earth pointing at the ocean, at the Atlantic Ocean. Okay, so it's important to know the context here. Okay, and so what we do is take the motion away from Joe, and this is the ether, and that's a snapshot of the ether, of his famous ether. Okay, that's what we got to look at. What is that thing? And not specifically the white stuff. I want to know what the black stuff that serves as contour, that gives shape to each little particle. That's what I want to know what it is. I mean, if the ether fills space, as they say, because empty space is full of ether, full of all these particles, I want to know what this empty space stuff is. That's the thing you want to get to the bottom of. We don't care about the ether. I can wipe that whole ether away. I don't care about it. I want to know what the black stuff is. Okay? So that's where we're headed. We're headed to finding out what space is. We want to know what nothing is. We want to know what vacuum is. And in the last 10,000 years, no one's defined the term. That's the problem. The problem that mathematical physics has, all these bozos from Einstein onwards to Stephen Hawking, all these people, they never define what nothing is. And so they end up saying, well, the vacuum is full of energy. It's full of fields, vibrating fields. All these virtual particles are hidden in there. They come in, they say hi, and they go back and form the ether. Well, they form it or they fill it. I mean, is this vacuum made of particles, or is the vacuum filled with particles? Well, if it's filled with particles, we have the situation we discussed last week. And that's that each particle is contoured. It has a shape, each particle, and something is giving it shape. What is giving shape to each particle? We call that space. We call that vacuum. What is that vacuum, that space? We're back to square one. We still don't know what space and vacuum is. We don't care about the particles. We don't care about the energy. We don't care about the fields. Because if those are taken as objects, fine. Let's concede for the sake of argument. Okay, those are objects. Let's remove the objects. What's space? What's the vacuum? Without all these things that fill the vacuum. And that's what they never define. So in science, in rational science and rational physics, very simple. Something, that which has shape. Nothing, that which doesn't have shape. Straightforward. They're antonyms. Nothing and something. And then we have all these words which are synonyms of them. And we start with the golden principle of physics. Physics requires an object. You cannot do physics without objects. If you remove all objects in the universe, there's nothing happening. What is something? Something is that which has shape. What is nothing? It's that which doesn't have shape. Nothing and something and nothing, they're antonyms, they're opposites. What are the synonyms of something? Everything that has shape or that designates that have shape. Object, thing, anything, medium, entity, body, substance, structure. All those words are perfect synonyms for the purposes of physics. What is nothing? Nothing is space, vacuum, emptiness, void, whatever other words, zip, zero. Okay, just think of any word that comes to mind. Nothing refers to that which doesn't have shape. Okay, and until Joe can, tell us what this space thingy is, he doesn't have a case. Okay, and again, in physics, there are only two possibilities, and the word in question designates that which has shape, object, or that which doesn't have shape, nothing. So we have objects and concepts. That's all there is, okay? And objects you can see on the left, you can see the shapes. We can name them. We can call them X, Y, Z if you want. It doesn't matter. We can call it elephant, rock, anything you want. Concepts, and you can see there we have the ether. Why? Because until someone can tell us what space is and whether ether has shape or not, and what contours each ball, that background, right now we have to treat it as a concept. We don't have an object yet. And so we can't say the ether did this or did that. Right now we don't have an object. Okay? And at the bottom you'll see quasi-particles and pseudo-particles, which I'll be talking about, and more nonsense that mathematical physics created in the last few years. They created pseudo-particle. It's not a particle. It's a thing trying to become a. It's a concept trying to become a particle. It's love trying to become a heart. It's a location trying to become a dot. You know the word point. It's a itinerary trying to become a line. You know, the stick that is used in geometry, and they say, look, this stick, we call it a line. Yeah, what is a line? It's an itinerary. It's a bunch of locations. It's a one-dimensional. One-dimensional? What do you mean one-dimensional? No such object, one-dimensional. Zero-dimensional points? That's the nonsense that these people have produced in the last 10,000 years. So yeah, this side is a little different. We have a different language. We have a different proposal for how this universe works. We're talking about mechanisms. And we're going to provide mechanisms. You're going to visualize. You don't have to take my word for it. You just look at the movie and say, look, I understand the movie. Do you believe in the movie? We don't care. That's your personal opinion. That's your personal religion. Some people believe, some people don't. That's fine. We're saying we're going to give you a mechanism that you can understand, that you can visualize. Say, okay, now I understand how magnetism works. Now I understand what electricity is. Now I understand how an atom works. Now I know what light is. Whether you believe or not, that's a separate issue, but that's the proposal that you're going to see, and you're going to be able to see it with your own eyes, and you won't have to take my word for it. You're just going to see it and say, well, does that sound rational to you? Well, it depends on how you were educated, how you grew up, who your father and mother was. You know, it depends on a lot of stuff. Okay? So, to round up, what we have is we have some irrational proposal for ether. And the irrational proposal is that, first, it cannot be infinite. And I discussed that last week, so anybody who wants to go into more depth can just look at the previous lecture, and we'll figure out what I'm saying there, hopefully, because this other fellow couldn't figure it out. So that's one issue. You're going to see what the arguments against the ether, the infinite ether is, and against the possibility that ether and space are one and the same. They're not identical. They can't be, because otherwise you would have no contrast, no contour to each particle. There would be no such things as particle, and you wouldn't have movement either. So you can't have space equal ether. You can't have an infinite ether or an infinite space for that matter. Why? Because the word infinite is an irrational term. We already discussed that as well. And again, you have to look at what we discussed. And then the only possibility is the one Joe was mentioning, which is an ether which has shape. And the only issue there, very simple, is just tell us what space is, what the vacuum is. Don't worry about the ether anymore. Just get rid of all those particles that are getting in the ways of our eyes. We want to know what the black stuff is. We want to know what space is. And if you cannot define space in any other way than, like I define it, that which doesn't have shape, then you don't have a starting point. You don't have a theory. We don't care to listen to your theory because you can't even get through your assumption. That's the issue. So work on your space, on your vacuum. That's the one we want to know. We want to know what space and vacuum is. No one figured it out in 10,000 years. Certainly no bozos like Einstein or Hawking figured it out. And no one coming after all these other celebrities like uh, uh, Sean Carroll and Michio Kaku and what is it, Green, Brian Green, Larry Krauss, all these bozos. What do they know about physics? They're mathematicians and they're celebrities. They're interested in their careers. They're not interested in doing science. They're not interested in really digging deep into these issues and finding out how a magnet works. Ask them how a magnet works. I mean, we already have Richard Feynman, another bozo who couldn't figure out how a magnet attracts another. And these guys call themselves physicists. They give each other Nobel Prizes. They don't know how a magnet works. They can't tell you how, they can't tell you this, how simple this is. I mean, here's two magnets, right? They can't explain that magic. And they say, well, our intelligence, we humans are not intelligent enough to understand that the intelligence of humans is not up to how the universe works. And so I keep saying, God comes here tomorrow. Mother Nature comes here tomorrow. Father Universe comes here tomorrow. Sits down right beside me. Sits right beside you. All we have is two pieces of metal. That's the entire system. You think that God, almighty, all-knowing, omniscient, right? He knows everything, right? He sits down beside me. He says, Bill, let me tell you how a magnet attracts another. Let me tell you the mechanism of how this magic works. Do you think you would understand him if he tells you this? If he tells you what the mechanism is? Do you think it'd be so unfathomable, inhuman to try to imagine how a magnet, two pieces of metal, how they attract each other, what the mechanism is? All you have to do is find out what's between these two stupid magnets. That's all you got to do. You got to figure out what invisible object is there. You can't do it with math. You can't do it with concepts like field or energy or whatever, mass or charge. No concepts allowed, not in physics. In physics, you got to put a physical object in there. And we have only two. Man, you got to make the invisible visible. That's what you got to do. All we have is two pieces of metal. So it can't be that difficult. This is kindergarten stuff. This is not something you need to go to college to learn. Okay? Another thing here. Okay, we let go of the pen and it falls to the floor. Always to the floor. Now, how difficult can that be? We have a pen in the earth, two objects, and the pen falls towards the center of the earth. The moon falls towards the earth falls towards the sun. It's only always two objects. Now, how difficult can it be? You think God comes here and explains it to us and we would not understand the mechanism? All you got to do is make the invisible thing that's keeping these two, that's mediating this transaction. You need to make the agent that's in there operating that space. You got to make it visible. That's all you got to do. It's kindergarten stuff. That's what we're going to do here. We'll see you next time. We'll see you, Wednesday. See you then. Bye-bye.